Welcome to the deep dive. Today, we are undertaking I think, a really critical mission, building the absolute foundations of ancient India.
Hmm.
We're going right back to the very, very beginning, a deep dive into the Paleolithic and Mesolithic ages.
Right.
And this material, drawn from core texts, is just essential, especially for anyone who needs that precise, structured, and really factually rigorous understanding of how human history kicks off in the subcontinent.
That's the challenge, exactly.
Yeah.
We're covering the longest single span of human existence.
Millions of years.
Right, the era of the earliest hunter-gatherers.
Right.
And our job is to unpack their journey, the geological, the biological, and of course the technological. It's all about building a solid framework, both chronologically and conceptually.
And when we talk about chronology, I think we have to start by just confronting the sheer scale of time we're dealing with. It's so easy to just throw around numbers like millions of years.
They lose their meaning.
Yeah. So let's try to put this in perspective with what we can call the grand timeline. Our planet, Earth, is, about 4.5 billion years old.
About that, yes. 4.5 billion years. And in that immense, incredibly complex drama of planetary evolution, human beings, anatomically modern Homo sapiens, we are incredibly recent arrivals.
Like the last few seconds of the movie.
Exactly. We only show up about 200,000 years ago. Geologically speaking, we've been, minor players for almost the entire show.
The very ability to even grasp this kind of deep time, it required a whole new intellectual toolkit, didn't it? One that was really only forged in the 19th century.
That's the key.
So what were the big theoretical breakthroughs that allowed archaeology to finally move beyond myths and legends?
There were really two major pillars. First, you had the geological revolution, which was led by Charles Lyell. His work, Principles of Geology, published between 1830 and 1833, it introduced this groundbreaking concept of uniformitarianism.
Uniformitarian, okay, so that's the idea that the same natural processes we see shaping the Earth today, things like erosion, wind, sedimentation.
Those are the very same forces that operated in the deep past.
Exactly. Before Lyell, a lot of people believed the Earth's history was dominated by sudden, singular, catastrophic events, like the biblical flood.
Right.
Lyell showed that actually, no, it was these slow, continuous processes that were responsible for massive changes over immense periods of time. This immediately pushed the accepted age of the Earth way beyond the few thousand years that prevailing chronologies allowed. It created the stage that was necessary for human prehistory.
So once that stage was set, the geological deep time was established, then the biological revolution followed, and that was led by Charles Darwin.
Darwin's The Origin of Species in 1859. It provided the mechanism for change on that stage. Evolution through adaptation and natural selection.
The survival of the fittest.
Right. And this was just biologically radical. It suggested humans were actually part of the natural world, not somehow separate from it.
And that connection to humans was made explicit almost immediately. It was. Thomas Henry Huxley, people called him Darwin's bulldog. He extended these ideas directly to our species in 1863 with his book, Evidence as to Man's Place in Nature.
So you have this 1-2 punch, vast geological time, plus biological descent from earlier forms.
And that combination had profound, and I mean deeply unsettling, implications for the 19th century worldview.
Because it challenged that deeply held idea of a static, divinely created world.
Absolutely. The idea that nature was constantly in flux and that humans shared a common ancestry with apes, it was just deeply disconcerting for many people. It implied unpredictability, contingency.
But it was that very theoretical shift that unlocked prehistory.
It was the key. Once scholars had a framework for deep time and evolution, they could finally go back and properly interpret all those flint tools that had been collected for centuries but, were just dismissed as thunderbolts or naturally formed rocks.
So that intellectual framework finally allowed scholars to make sense of findings right here in the subcontinent. This is where we lay the foundations for Indian prehistory. Where does the timeline of discovery really begin for us locally?
Well, the first reported find that we now attribute to the Stone Age came in 1856. A railway engineer, a man named Le Mesurier, he found a small chert arrowhead near a place called Nagurhi in central India.
Just a single artifact.
Just one, but it was a signal. It pointed to the presence of a much deeper history.
But the true landmark moment, the one that's seen as the formal beginning of Indian prehistory, that's generally dated to 1863, right?
That's the one. That's when Robert Bruce Foote, a geologist working with the Geological Survey of India, discovered the first Paleolithic hand axe in India at Pallavaram near modern-day Chennai. And Foote didn't just stop there. He went on to document over 400 sites. He provided the very first systematic classification of Stone Age materials in the region.
And the recognition for this was pretty much instant and global.
It was. Foote's tools were actually displayed at the Vienna International Exhibition in 1873. That put South Asia firmly on the map of human origins research, right alongside Europe and Africa.
Okay, so today we have thousands of sites. But for our listener who's trying to build this framework, what are the primary sources of knowledge beyond those famous hand axes and arrowheads?
Well, stone tools are obviously the most common artifact just because they survive so well. But we rely on a whole mosaic of evidence.
Okay.
This includes things like structural remains, post holes, for instance, which might suggest a temporary shelter, or even paved floors. We look for burials, which can tell us so much about social structure. And critically, we rely on plant and animal bones to reconstruct diet and environment, and later on, rock art, which gives us these amazing cultural insights.
And the context of these tools is everything, isn't it? I mean, finding a beautiful hand axe doesn't tell you much if you don't know where it came from.
Context is absolutely everything. We categorize finds based on their relationship to where they were originally made or used. So a primary context means the artifact is found exactly where it was left. Untouched. Semi-primary means it's been moved a little, maybe washed a short distance. But a tool in a secondary context, let's say you pull it from a river deposit miles away from any known site, that tells you more about geology and sediment flow than it does about human activity.
Right. So let's say we find a tool in a person primary context. How do archaeologists figure out its actual function? How do we know if a sharp flake was used for cutting hide or for, say, scraping wood?
We use three main methods, and they're quite sophisticated. First, there's experimental tool making.
So making them yourself.
Archaeologists actually replicate the tools using the same materials and methods. It helps you understand the skill required, the difficulty, and how efficient the final product is. Second, we use ethnographic parallels, cautiously studying modern stone tool-using communities to infer potential lifeways.
You have to be careful with direct comparisons, I imagine.
Very careful. But the third method, which you mentioned, is microwear analysis.
Which I think is just brilliant.
It is. Microwear analysis involves taking the artifact and examining its edges under a powerful microscope. Different activities, cutting plants, chopping bone, processing soft hide, they all leave distinct telltale patterns of wear and polish on the stone.
So you can move from just classifying it, this is a scraper, to actually defining its function. This scraper was used to prepare animal skins.
Exactly. That's a huge leap in understanding.
Given how demanding and essential tool-making was for survival, who was actually doing the work? Who was chipping away at these stones?
Well, historically, the image has always been the male hunter making his spear point.
Right, the classic image.
But modern analysis suggests a much more complex reality. Given the active involvement of, both men and women in all aspects of staying alive, hunting, gathering, processing food, making clothes, building shelters, it's highly probable that both sexes were involved in the skilled labor of creating stone tools. It was a community effort.
That's a great point. It shifts the focus from just the tool to the entire community using it. So let's step back for a moment and look at that global human lineage before we focus back in on India. The story starts in Africa, roughly 2 million years ago.
Correct. We place human history firmly within the Cenozoic era, and specifically in the last two epochs. The Pleistocene, which is the Ice Age epoch, starting about 1.6 million years ago, and the Holocene, our current epoch, which starts about 10,000 years ago.
And the lineage itself, it begins with Australopithecus.
Yes, the earliest hominids we know of. They existed between about 4.4 and 1.8 million years ago, and they were confined strictly to Africa. They were bipedal, but their brains were small, and they weren't confirmed toolmakers.
Okay, so then around 2 million years ago, we see the genus Homo appear, starting with Homo habilis, the handyman.
That's right, at sites like Olduvai Gorge. These were the first confirmed makers of stone tools, although it's interesting, the oldest tools we found actually predate each habilis just slightly, appearing around 2.5 million years ago.
So after habilis comes Homo erectus.
Appearing roughly 1.7 million years ago in East Africa. And H. erectus was the first hominid to fully master walking upright, bipedalism, and that led to a massive geographical expansion across Asia. We find their remains in Java, in China.
And a much larger brain.
Much larger, averaging around 974 cubic centimeters.
And then finally, the emergence of us Homo sapiens, anatomically modern humans.
They emerged in Africa somewhere between 195,000 and 150,000 years ago. And this is what sets up that great academic debate. The out-of-Africa model versus the multi-regional evolution model.
Right. Did we evolve entirely in Africa and then replace everyone else, or did we evolve simultaneously in different places?
The prevailing evidence right now strongly supports the out-of-Africa hypothesis, but it's a story that's always being updated with new finds.
Okay, so we have the lineage. Before we dive into the scattered evidence in India, we need to really lock down the criteria. What biologically and culturally defines us, Homo sapiens? What are the key features?
Biologically, we're looking for four main things. First, true bipedalism, walking upright efficiently. This requires an S-shaped backbone, longer legs, specific arches in the feet, and critically, it frees the hands for carrying and tool use.
Okay, that's one.
Second, prehensile hands. This is facilitated by a large, fully rotating thumb that allows for a precision grip, the very thing you need for making intricate tools.
Third.
A change in the face and jaw, so a smaller jaw structure and, crucially, non-protruding canine teeth. This reduction is often seen as correlating with a less aggressive or more socially complex environment, a world where cooperation and communication become more important than brute force.
And number four, the one everyone points to, brain size.
Increased brain size, yes. The modern human brain averages about 1450 cc. But the key insight here isn't the absolute size, it's the size relative to our body weight.
The ratio.
The ratio. It suggests more computing power is dedicated to cognitive function advanced planning, memory, complex communication.
And these cognitive advancements are then reflected in cultural traits.
Precisely. We are defined culturally by our ability to actively manipulate and transform our environment through specialized, innovative technology. We see the organization of living space, not just camping randomly, but structuring camps with designated areas for work and sleep. And, most uniquely, symbolic thought and expression, which we see in art, organized rituals, and formal burials.
Some scholars argue there's a gap, though, a gap between being anatomically modern and behaviorally modern.
That's a very important debate.
Yeah.
While we might have looked like modern humans 200,000 years ago, fully modern, behavior complex, symbolic art, specialized technology, tailored clothing that might have only appeared much, much later, perhaps around 50,000 years ago, coinciding with what's called the Upper Paleolithic Revolution.
So given these really strict criteria, both biological and behavioral, how do we classify the tantalizing, but let's be honest, very fragmented early human evidence found right here in India?
The record is challenging. I mean, the early finds focused on what they call the god apes of the Sewalics, things like Ramapithecus and Sapopithecus, dating back 10 to 14 million years.
But they're not direct human ancestors.
That view has been largely revised, no. They're now considered closer to the ancestors of the orangutan line or other non-human hominoids.
So if we set aside those older ape fossils, the truly early human record becomes incredibly sparse, which is what makes the 1982 Hafnora discovery so globally significant.
Absolutely. In 1982, Arun Sanakia of the Geological Survey of India found a fossilized cranium fragment, a skull cap at Hafnora in the Narmada River Valley.
A crucial location.
Critical, because the find was directly associated with vertebrate fossils and late Acheulean tools.
So what was the immediate identification of this ancient resident of the Narmada?
The fragment belonged to a woman, probably around 30 years old. Sanakia initially classified her as an advanced Homo erectus, and he named her Homo erectus narmadensis.
And that was based on her cranial capacity.
Yes, it was large, estimated between 1155 and 1421 cc, which puts her right at the upper limit of the H. erectus range.
But I understand that identification is still very much debated among scholars.
It is. And this is a key point for any student of the subject. Many scholars argue the morphology of the skull, its robustness and its size, suggests she might actually be an early representative of archaic Homo sapiens.
And if she were archaic Homo sapiens, that would just dramatically reshape the timeline of human evolution in South Asia.
It would. The date is still uncertain, but the current consensus places her somewhere in the early Middle Pleistocene, perhaps around 500,000 years before present.
And subsequent searches near Hafnora have added to the puzzle.
They have. Between 1983 and 1997, further searches yielded a hominid clavicle, a collarbone, found in the same deposit. It's dated to between 500,000 and 200,000 years ago, and it's plausible, though we can't be certain, that it belonged to the same individual.
So besides Hafnora, what other authenticated human fossil evidence do we have from India?
The finds are minimal. We have a complete fossilized human baby skull found at Udai in Tamil Nadu, which was situated directly under Upper Paleolithic deposits, so that suggests a more recent presence. And we have to look beyond the mainland.
To Sri Lanka.
Yes. Sri Lankan sites like Faihinlina have yielded remains of anatomically modern humans dating back between 37,000 and 10,500 years ago.
So what's the ultimate takeaway from this really minuscule fossil record compared to what we have from Africa or Europe?
It means that the current story of human evolution in India is largely based on tools and ecology, not on skeletal remains. And that makes every new discovery, every new gating technique applied to a site like Hafnora potentially revolutionary. Our understanding is still heavily reliant on indirect evidence.
So to interpret that indirect evidence, we have to understand the environment these early humans were adapting to. Let's shift to the paleo-environmental context, the dramatic forces that shaped the subcontinent.
Geologically, we always have to remember that peninsular India was once part of that great southern landmass, Gondwanaland. The environment we see today is a result of immense tectonic forces.
The Indian plate colliding with Asia.
A collision that's still happening. The Indian plate is still pushing into Asia at about 5 centimeters per year. And this causes the Himalayas and the Tibetan Plateau to rise continuously, about 5 to 10 millimeters annually. This constant uplift leads to seismic activity, and critically for our story, it generates immense volumes of sediment that are carried by rivers like the Ganga and the Yamuna.
And that sedimentation is what created the incredibly fertile northern alluvial plain.
It did. And the Pleistocene was defined by the drama of this massive geological activity colliding with global climatic change, that alternation of ice ages and interglacials happening globally.
And in tropical regions like India, how did that play out?
It generally translated into cycles of extreme dryness or wetness. We call them interpluvial and pluvial periods. The rhythm is complex and it varied regionally, but the big picture is that the Pleistocene was characterized by a highly volatile climate, which demanded continuous adaptation from hominid populations.
We also mentioned an external event with a huge impact, the Toba supereruption.
Yes, this was a massive volcanic eruption in Sumatra about 75,000 years ago. Ash deposits from this event have been found embedded in river valleys all across central and peninsular India.
This event is often linked to the bottleneck theory globally. What does that debate mean for the Indian context?
Well, the global bottleneck theory suggests the Toba eruption plunged the world into a volcanic winter, drastically reducing human populations, maybe to just a few thousand individuals worldwide.
A near extinction event.
Potentially. However, the evidence in India really complicates this view. While the eruption certainly caused complex environmental shifts, some sources suggest that the effect on hominid populations here might have been more localized. Or maybe they proved resilient, surviving in little environmental pockets or refugia.
So the story in India might not have been a complete wipeout?
The presence of tool industries shortly after the Toba event suggests that's a possibility, yes.
And regional studies show that even in places we think of as harsh, like the Thar Desert, the environment was very different back then.
Oh, absolutely. Take Didwana in Rajasthan. Paleo-environmental studies show that for most of the Pleistocene, the Thar region was far wetter than it is today. There was surface water available, supporting a much richer ecosystem, which explains the high density of lower and middle Paleolithic sites we find there.
So it was a much more inviting landscape.
For a long time, yes. The region only became significantly drier towards the end of the Upper Pleistocene.
Okay, so we're building a picture of adaptation. Humans surviving massive geological uplift, alternating cycles of wet and dry, and even supervolcanic events.
With that background, we can now start to impose the analytical structure that lets us manage this vast timeline. The core classification is the 3H system stone, bronze, iron, which was later refined by John Lubbock in 1863. He's the one who split the Stone Age into Paleolithic and Neolithic.
And the Paleolithic itself was then broken down further by Edouard Lartet into lower, middle, and upper, based primarily on how the tool technology evolved.
Right.
So for our listener, we need to lock down the specific chronology for India. These are the key time frames.
These are the critical periods, all rooted in the Pleistocene era. First, the Lower Paleolithic, from about 2 million years ago up to 100,000 years ago. This is defined by heavy core tools.
Okay.
Then the Middle Paleolithic, from roughly 100,000 to 40,000 years ago, defined by more refined flake tools.
Right.
The Upper Paleolithic spans from 40,000 to 10,000 years ago. This is the age of long blade technology. And then finally, the Mesolithic and Neolithic, which belong to the Holocene, the period after the Pleistocene.
Great. So let's focus on that first, longest period, the Lower Paleolithic, the age of core tools. What defined the technology and the raw materials they were using?
The technology relied on large core tools, made from coarse-grained stone like quartzite. The manufacturing methods were pretty basic and physically demanding. It was mostly direct percussion, just smashing one stone against another.
Brute force.
A lot of it. They may have also used crude methods like heating stones and then dousing them with cold water to cause large usable fragments to shear off.
Okay, so to really understand the differences between these phases, we have to get the vocabulary right. What's the fundamental difference between a core and a flake?
It's simple but crucial. The core is the original larger piece of stone that remains after the toolmaker has struck it. The flake is the smaller piece that is struck off. Lower Paleolithic tools are primarily made from the core itself.
And within those core tools, we have the chopper and the chopping tool. What's the distinction?
A chopper is a large tool that's only worked on one side to produce a cutting edge. It's unifacial. A chopping tool, however, is flaked alternately on both sides of the core to produce a wavy and generally sharper cutting edge.
Bifacial.
Exactly.
And then we get to the signature technology that really defined the later part of the Lower Paleolithic, not just in India, but globally. The Acheulean tradition.
Yes, the Acheulean complex is defined by the appearance of these advanced, symmetrical, and purposefully shaped large tools, specifically hand axes and cleavers.
So a cleaver, what is that exactly?
A cleaver is a flattish tool, often made on a large flake, and it's characterized by a broad, straight cutting edge at one end. Think of it like a stone butcher's knife, designed for heavy cutting.
And as we look at the evolution of this Acheulean tradition, do we see a clear increase in planning and refinement over time?
Absolutely. Early Acheulean tools are thick, a bit clumsy, asymmetrical. Late Acheulean tools, the kind we find associated with the period of the Hathnora skull, are beautifully thin, symmetrical, and they show evidence of really careful preparation and trimming. This shift reflects a huge increase in cognitive capacity for design, long-term planning, and controlled flaking.
So moving on to site evidence and dating, what is the absolute earliest evidence of stone tool use found in the subcontinent?
The earliest firm evidence we have comes from Rewat in Pakistan. Stone artifacts embedded in the Pinjar bed of the Siwaliks have been dated to an incredible 2.01 million years ago.
Wow, so that potentially places tool use in South Asia almost as early as the first African evidence.
It's in the same ballpark, yes. It's a huge deal.
So that sets the upper limit. What about absolute dates for the core Lower Paleolithic period in India proper?
We have several key dates that ground the Middle Pleistocene occupation. Didwana in Rajasthan dates to around 390,000 BP. Navasa in Maharashtra and Yidawadi in Karnataka both show occupation around 350,000 BP. These dates confirm a widespread human presence across very different ecological zones long before the next phase.
The types of sites you find also tell us about their economic organization. Let's talk about factory sites.
Factory sites are crucial. They're found where the raw material was sourced and processed. They're littered with thousands of unfinished tools, flakes, all the debris of manufacturing. Anandpur in the Badarpur Hills near Delhi is a perfect example. It was a massive habitation and factory site right next to the quartzite source. People lived there to exploit that resource.
And what about habitation sites? How did these early groups organize their living space?
The evidence is sparse, but what we have is highly significant. At Bhimbetka, which we'll talk about later for its art, archaeologists identified 5 distinct floors that were paved with flat stone slabs, and they've been attributed to the Lower Paleolithic.
Paved floors.
Paved floors. It suggests an early, purposeful effort to organize and define a living space. It's a move beyond just random camping towards a recognizable settlement structure.
Okay, so as we move from the Lower to the Middle Paleolithic around 100,000 years ago, we see this massive technological shift. We're no longer in the age of core tools.
That's right. This marks the move to the age of advanced flake tools. The focus shifts entirely from making tools from the core to using the specialized flakes that you strike off the core.
And these tools are different.
They're smaller, lighter, and much more varied. You get specialized tools like scrapers, points, and borers, all made from finer-grained materials like jasper and agate.
So while the old core tools were for heavy-duty work, these new flake tools were for specific, finer tasks. The real cognitive leap here seems to be the prepared core technique. It requires so much more foresight.
Absolutely. The defining innovation is the leveloir technique, named after a suburb near Paris. So instead of just striking the core randomly, the toolmaker carefully prepares the core first. They flake the sides and the top to shape it, almost like a tortoise shell, creating a convex surface.
So the core itself becomes the template for the final tool.
Exactly. The final act involves creating a striking platform and delivering one single controlled blow. The flake that comes off is already pre-shaped, it's thin, and it's remarkably sharp. The tool is designed before the final blow is even struck.
That is an incredible degree of planning. And how did that contrast with something like the discoid core technique?
The discoid technique also involved shaping the core, but it produced multiple, smaller, less standardized flakes. The Levallois technique was all about producing one highly superior, predetermined flake, a tool of real precision.
And with these new technologies, do we see specific regional industries emerge?
We do. The Middle Paleolithic industry of central and peninsular India is often called the Navasan industry, named after the site of Navasa in Maharashtra. Meanwhile, the assemblages found west of the Yarra Valleys in the Thar region are known as the Luni industry.
And what about the climate during this Middle Paleolithic phase?
Well, in regions like the Thar, the tools are associated with reddish-brown soil deposits, which suggests a cooler, wetter, and more humid climate than what came before. The dates from Didwana place this more favorable environment at around 150,000 BP.
Okay, now we move to the Upper Paleolithic, starting around 40,000 years ago. This is the final phase of the Pleistocene, and it's known as the Age of Blades.
This is really the era of modern humans, technologically speaking. The key advance was the ability to manufacture these long, narrow, parallel-sided flakes we call blades. You can think of it as a kind of standardized mass production. It's much more efficient. You get more cutting edge from the same amount of raw material.
And we also see a big increase in burins. Burins are interesting. They're described as having a thick, sort of screwdriver-like working edge. What were their specialized functions?
Burins weren't really cutting tools in the traditional sense. They were specialized engraving tools. And crucially, they were used to carve deep grooves or slots into hard materials like bone, antler, or wood. And this was absolutely vital for the advancement of hafting.
Hafting attaching the stone tool to a shaft or a handle to create a composite tool like a spear or an arrow.
Exactly. The ability to make a sturdy slot in a spear shaft was essential for securing that stone blade or point firmly. It shows a really sophisticated approach to tool assembly.
Environmentally, this phase correlates with increasing dryness in the north and west of India, pushing adaptations towards smaller, more efficient toolkits. Let's look at some key site evidence. Rewat gives us an early date, but the Kernel Caves are truly unique.
The Kernel Caves in Andhra Pradesh are the only sites in India that have provided conclusive evidence of bone tools in an Upper Paleolithic context. In some excavations, bone tools, points, scrapers, awls, they accounted for up to 90% of the recovered tools.
90%.
90%. This suggests a very specialized use, maybe for processing hides, delicate carving, or manufacturing textiles. It reflects a local environment that suited bone as a primary raw material.
We also find some early, tantalizing hints of subsistence changes in the Belan Valley.
The faunal remains from the Belan Valley showed bones of wild cattle alongside sheep and goats. Now, because sheep and goats are not native to that specific area, their presence suggests they may have been introduced from the northwest.
So potentially a very early step towards animal management.
Potentially, yes. Long before the true Neolithic period.
And finally, we get definitive proof of these composite tools from microwear analysis at sites like Baghor III.
The microwear analysis at Baghor III in the Sun River Valley was conclusive. It showed specific wear patterns on tools that confirmed specialized craft work, boring, scraping, whittling. But most importantly, it confirmed polish and wear marks right where the stone tool meets the handle, providing tangible evidence that these tools were indeed hafted.
That brings us out of the Pleistocene and into the Holocene around 10,000 years ago. This transition defines the Mesolithic age, a post-Ice Age culture with miniature tools, in a world that's becoming warmer and wetter.
The Mesolithic is still essentially a hunting and gathering culture, but it's set against a much more favorable climatic backdrop that allowed human communities to expand and colonize new, diverse ecological niches. This leads to much greater regional specialization.
And the defining artifact of this age is the microlith. Let's define these miniature tools precisely for our listener.
Microliths are tiny stone tools, ranging in size from less than a centimeter up to about centimeters. They're crafted from extremely high-quality, fine-grained materials, chert, jasper, agate, chalcedony.
And that choice of material is key, isn't it?
It's everything. Its structure allows for the controlled, precise flaking you need to make such small objects.
And they come in two main types, reflecting different functions.
That's right. They're classified as non-geometric types, which are simple blades, points, and scrapers, And the more famous geometric types, which include lunates or crescents, triangles, trapezes, and rhomboids.
And their tiny size is proof of their ultimate purpose to form composite tools.
Exactly. Microliths were rarely used on their own. They were produced in large numbers and then carefully inserted into grooves that were cut into handles made of bone, antler, or wood.
So they would form the sharp, serrated edges of knives or arrowheads.
Or spearheads, or even sickles for harvesting wild grasses. Some of the points may have also been treated with poison to make the arrows more lethal.
The warmer climate and better environment led to a population increase and a spread of settlements. We see varied levels of sedentariness. What constitutes evidence of a more settled life in the Mesolithic?
We find evidence of repeated, long-term occupation at sites like Sarai-Naharai, Mahadaha, and Damdama in the Ganga Valley. These sites have thick occupational deposits and heavy artifacts that you just wouldn't carry around if you were fully mobile.
Like grinding stones.
Exactly. Large grinding stones, cairns, and mullers. While they weren't permanent villages in the later Neolithic sense, they were reliably revisited for long stretches of time.
This is also the period where the academic debate about the transition from wild harvesting to early food production really heats up, specifically around animal domestication.
This is a highly controversial area. Sites like Begor in Rajasthan have reported faunal evidence that suggests domesticated species, with cattle and sheep-goat being identified in high percentages. Adamgarh in Madhya Pradesh also reported early domesticated species.
But the challenge lies in the dating and whether those animals were truly genetically domesticated or just being managed in the wild.
That is the critical counterpoint. Particularly in the Ganga Valley sites, Sarai-Naharai, Mahadaha, and Damdama, many scholars find no definitive evidence of domesticated animals at all. The fauna consists primarily of intensively hunted wild animals, like swamp deer and wild cattle.
So no domestication there.
Not conclusively. And while wild rice has been reported from late Mesolithic levels at some sites, firm, large-scale evidence for organized agriculture really belongs to the next period, the Neolithic.
So the Mesolithic sets the stage, but they weren't full-fledged farmers. However, the evidence for long-distance resource procurement suggests a very sophisticated level of organization, even without agriculture.
Oh, the organization becomes very clear when you look at the raw materials for the tools. Take Gurcharan Khanna's study of the chalcedony used at the Begor site. While local quartz was available, the Mesolithic toolmakers there preferred high-quality chalcedony for their small blades.
Because it had better flaking properties.
Exactly. But where did this preferred material come from?
That's the question.
It was sourced from the Deccan Traps, roughly 90 kilometers to the southeast.
90 kilometers, that's a long way.
It is, and it requires a logistical explanation. Either the Begor community undertook long, seasonal treks to get the stone, maybe following grazing herds, or, more likely, they were getting it through an established, stable exchange network with other groups who lived closer to the source.
And that completely changes the picture of small, isolated bands. We're now looking at interaction, trade, and regional resource management on a scale we haven't seen before.
As populations grew and became more tied to specific local resources in the Holocene, the internal complexity of these societies rapidly increased. The standard model suggests Paleolithic and Mesolithic groups were small bands organized by kinship with communal ownership of resources.
But we really need to challenge that old stereotype of hunter-gatherer life as just this brutal, nonstop struggle for survival.
That stereotype just doesn't hold up. Ethnographic studies suggest that because their technology prevented hoarding, hunter-gatherers had limited material wants. Once their daily needs were met, they often enjoyed significant leisure time. And many groups practiced conscious resource restraint to avoid overexploiting their local ecosystems.
And women's roles were critical.
Absolutely. Since plant food was such a reliable staple, women, as the primary gatherers, contributed massively to the subsistence base.
The most compelling evidence for this increased social complexity, this shift toward a fixed corporate identity, it comes from the formal burial practices found in the Ganga Valley Mesolithic sites.
Sarai-Naharai, Mahadaha, and Damdama.
Yes.
These sites are unique for their formal cemeteries. Bodies were generally laid in oblong or elliptical graves, often extended, with a very distinct west-east or east-west orientation.
And the skeletons themselves tell a story.
They do. They show good dental health, but high rates of osteoarthritis from hard physical labor. And very few individuals survive past the age of 40.
And the grave goods, the microliths, bone rings, shells, they suggest not just a belief in an afterlife, but possibly social differentiation.
Yes. But the most profound insight comes from UC Chattopadhyay's hypothesis about why these cemeteries are where they are. He argues that a formal cemetery, especially one where the burials align with the full annual path of the sun, suggests the sites were occupied year-round,
Okay.
and that the group was making a long-term territorial claim.
Why would they need to stake a claim so formally?
Because of increasing population pressure and competition over reliable, localized resources. Chattopadhyay suggests the key resource was the nutrient-rich aquatic fauna fish, shellfish, tortoise found in the perennial waters of the Ganga Valley. It provided a predictable food supply.
So the burials are a way of saying, this is our land.
This is our ancestral land. Formal burials tied to ancestor worship were a way for the group to assert a permanent claim over this critical territory. This is tangible evidence of social complexity and territoriality before the adoption of large-scale farming.
That makes the Mesolithic not just a technological transition, but a sociological revolution. Now let's look at the cultural expression of these societies. The birth of art. What evidence do we have of Paleolithic art?
Indian Paleolithic art is extremely rare, and it's often portable, not painted on walls. The earliest evidence is debatable but fascinating. 7 cupules, small cup-like depressions found in the Bhimbetka Auditorium cave. These deep, deliberate marks may represent ancient community rituals and are dated very early, near the lower middle Paleolithic boundary.
And the small symbolic artifacts from the upper Paleolithic.
The presence of ostrich eggshell fragments at Petni and Bhimbetka is key. This dates to roughly 39,000 to 25,000 BP. The ostrich roamed India back then, and these fragments were meticulously crafted into beads and discs.
Which would require a lot of skill.
A huge amount of skill. And it signals non-utilitarian abstract thinking. You're crafting an object not for use, but for symbolic value or adornment.
And then there's the most dramatic evidence of a spiritual life, the Baghora Shrine.
This site, in the Sun River Valley, dated around 9,000 to 8,000 BCE, provides clear evidence of ritual organization. It featured a circular sandstone platform, and on it was placed a naturally triangular stone icon. This stone had to be painstakingly reassembled from 10 fragments, suggesting it held immense symbolic value.
Possibly representing a goddess or the female principle.
That's the interpretation, yes. It reflects deep-seated religious concepts.
But the true explosion of art comes in the Mesolithic, and it's centered on the magnificent rock shelters of Bhimbetka.
Vishwakarma's discovery of Bhimbetka in 1957 was just monumental. It revealed this massive cultural archive. Out of 642 rock shelters, nearly 400 contain art paintings, engravings providing an unparalleled window into Mesolithic life in central India.
What are the dominant themes? What were they painting?
Animals dominate the scenes. 29 different species are depicted, including extinct megafauna like the rhino and the wild lion, which gives us unique environmental data. Interestingly, no snakes.
No snakes.
None. The colors are striking white from limestone and various shades of red from iron oxide or jarrah. And the styles are so dynamic, they convey a real sense of movement and energy.
And it's much more than just hunting scenes, right? They show social life.
Oh yes. You see detailed hunting scenes, often with dogs assisting and complex traps. But crucially, you also see the division of labor. Men are shown hunting, while women are depicted gathering and preparing food, grinding seeds on querns. We even see depictions of clothing and hairstyles.
So what about the ritual significance of this art? Was it private, like some of the European cave art, or was it public?
Unlike the deep, dark, private sanctuaries of many European caves, the Indian rock paintings are usually in well-lit, easily accessible areas. Furthermore, the sheer scale of some of the large, multi-layered paintings would have required community cooperation, maybe even scaffolding, to execute.
So it was a group activity.
It suggests a group ritual. And features like fantastic animals, the famous Bhimbetka boar, which seems to be a composite of a boar, rhino, elephant, and buffalo, and scenes of masked dancers. They all suggest profound, ritualistic, and cultic meanings, reinforcing group identity.
What an incredible journey, millions of years of adaptation and innovation. Let's try to synthesize the core achievements of these 2 longest periods of human history in India.
Okay. The Paleolithic was the longest phase, and it was defined by that continuous technological evolution. It moved from the heavy, unrefined core tools of the lower phase.
To the high-control flake tools of the middle phase with the level law technique.
Exactly. And culminating in the standardized blades and evidence of composite tools in the upper phase. This is the period that records the first tangible hominid presence at Hathnora, and it defines human survival against those dramatic Pleistocene climate shifts.
And the Mesolithic, then, marks the great sociological pivot.
The Mesolithic is the transitional culture of the Holocene. It's defined by the rise of microliths and the sophistication of composite tools. It saw dramatic increases in population density and regional specialization. And crucially, the evidence from formal cemeteries, long-distance trade, and rich rock art demonstrates the emergence of complex social organization and territoriality, even while most groups were still hunter-gatherers.
The detail we now have about how these early societies were organized, their ability to manage resources, structure their spiritual lives, plan their tool designs, it's truly astonishing given their technological limits.
And what's fascinating, and what connects the Mesolithic society all the way back to our early definitions of humanness, is how quickly the need for organization manifested once resources became fixed and predictable.
We discussed Chattopadia's hypothesis about the Ganga Valley communities staking these corporate claims over aquatic resources with their formal year-round cemeteries as evidence.
And this provides a powerful final thought. It suggests that competition over stable, localized food sources, whether it was fish or shellfish, was a sufficient driver for profound social complexity, for territoriality, formal cemeteries, even early signs of social ranking. All of these critical elements of structured society predate the invention of agriculture.
Which raises a really important question for you, the listener, as you categorize this foundational history. To what extent did rising populations and competition over reliable, localized food sources, not necessarily the introduction of the plow drive, the establishment of rigid social order, and the concept of permanent territory, before the Neolithic agricultural revolution even began?
It forces us to rethink the entire timeline of social complexity. Thank you for joining us on this deep dive into ancient India.
We'll catch you on the next deep dive.